Two really important skills in working and troubleshooting MPLS are the ability to manipulate the transport address that's used, as well as the router ID that LDP is going to choose. And in this video, we'll take a look at both of those. Let's jump in. Here are the opt-out questions for this video. Take a moment, review the questions, and if you're comfortable with all these topics already, hey, I'll see you in the next video. For everybody else, let's dig in. Now, how exactly does a router decide on its LDP router ID? And the answer is, if it is configured manually by an administrator who says, this is the interface IP address that I want you to use, then that's the IP address it's going to use. If we don't configure one manually, it's going to be the highest IP address on any loopback interface at the moment that LDP comes up. And if we don't have any loopbacks, it would be the highest IP address on any other interface at the moment that LDP is brought up. And one of the reasons that this LDP router ID is so important is because by default, that is going to be the transport address that's advertised in the little hello messages. So when R2 is saying hello, it's going to advertise its transport address in that hello message. And then when establishing the LDP sessions, the neighbor is going to try to connect to that transport address. So for example, let's say that our highest loopback was 192.168.1.2 here on router 2. Well, if that loopback is configured and it's the highest IP address of any of the loopbacks, and we haven't done anything manually, and we haven't done anything specifically to configure a transport address, that IP address will be both the router ID and the transport address for R2. Now, if this IP address is not reachable, meaning R3 says, I have no idea how to get to 192.168.1.2, that is effectively the end of the beginning. We have no LDP session that will be established between R3 and R2 because R3, if he doesn't know how to get to that address, won't go for it. So if that is the case, we have some solutions. Number one, we could manually configure the router ID to be a reachable interface on this router, like a reachable loopback that's advertised in the IGP. Or we could train R3 with a static route, I suppose, on exactly how to reach 192.168.1.2. Although a lot of static routes in our network is not a handy or fun thing to manage. Or another option is we could configure a transport address. We could go to this interface, for example, on R2, gig 2/0, and the IP address on this interface is 10.23.0.2, and we could tell that interface, in interface configuration mode, please, when you send out hello messages on this interface, go ahead and use the IP address of this interface as the transport address that's part of the payload in this hello message. And if we tell it that, not only will the source IP address of the packet being sent in the hello be coming from 10.23.0.2, but also the transport address, the advertised address inside that LDP hello, it will also have the address of 10.23.0.2, which R3 does have access to because it's directly connected, and that could solve the problem of reachability for the LDP neighborship. So this router ID and the transport address are linked by default. So we can manually specify what we want that router ID to be by pointing to a loopback that we choose. Or if we simply want to manipulate the advertised transport address, we can do it on the router so that the transport address will be what we want it to be in this example and not be the router ID. And one other item that's also very important is that regardless of what that transport address is, whether we inherited it from the LDP router ID or we configured it on the interface, if R3, when he sees those hello messages, if R3 has a route back to that IP address, but it's not through this interface, that will cause R3 to not form that neighborship as well. So we want to make sure that R3, on the interface that he hears the hellos on, that's also the interface he has in his routing table to reach that transport address, regardless of what it's set for. So let's take a look at the impact of that router ID and the transport address. Now I have rebooted this gear a few times since our last video, so let's just validate our path all the way from R1 down to that loopback 5, which is on R5. This should verify that we have connectivity, and it should also show us the MPLS labels that are being imposed in that path. And R1 is saying, okay, the label I need to impose is label 221, and then R2 swap that for label 323. And then R3 swap that for label 415. And because R5 is directly connected to 5555, it had advertised the implicit null, which causes R4 to go ahead and pop off the label and send the packet as naked IP down to R5. And that popping right before the last router is called that PHP, the penultimate hop pop. And that's why we don't have a label on this last leg of our journey, because R4 popped it off. So that part looks great. Let's go to the middle. Let's go over to R3. And on R3, let's see what R3's current MPLS router ID is. Now, it has a loopback of 3333. That's its only loopback. So I'm expecting that the LDP router ID is going to be 3333. So I'm going to scroll up just a little bit so we can see that command, which is right here. Show MPLS LDP discovery detail. And there's our identifier. So it's 3.3.3.3 with the 0 representing we're using system-wide label space on R3. It also says it's got the opportunity to learn and discover neighbors on gig 2.0 and gig 3.0, which are also enabled for MPLS. And it says right here in my hello messages, I'm advertising that my transport address is 3333, which matches the router ID by default. And on gig 3.0, our hello messages are indicating that our transport address in the advertisements are 3333. So that all looks healthy. Now next, just for fun, let's do this. Let's go ahead and tell R3 that instead of using 3.3.3.3 by default, because it's the highest IP address on a loopback, let's tell it to go ahead and use gig 2.0's IP address, which is 10.23.0.3, as its LDP router ID. Now that address is reachable definitely by R2, and it's also reachable by R4, because this network 10.23.0.0 is part of OSPF. It's part of the IGP. So if we change R3's router ID to 10.23.0.3, it shouldn't pose a problem for R2 nor R4. It will reset the existing LDP sessions, they'll reestablish, and for the short duration of time that it's renegotiating those LDP neighborships, we will have a failed LSP for just a moment while it reconverges. So let's go ahead and do that. We're going to change the LDP router ID to the IP address on gig 2/0. Now the command to do this in global config is MPLS LDP router ID and the interface you want to use, and then the keyword force, which says please do this now. And it indicates that we lost a couple neighbors and we got back a couple neighbors. So if we make a little road trip just for testing and we use the magic up arrow key to do that trace again, we still have our LSP in place, which implies that R3 renegotiated with R2 and R4 and those LDP sessions came back up. And we could verify what our current LDP router ID is the same way we did before, just adding the do command because I'm in configuration mode. And if I scroll up just a little bit, so now it's showing us that our ID for the router is 10.23.0.3. Fantastic. And it's also indicating here that the hellos that we're sending out on gig 2.0, which is this interface going over to R2, is 10.23.0.3, which matches the LDP router ID. And on gig 3.0, which is this interface here going over to R4, we're also advertising a transport address of 10.23.0.3, which again causes no problems for either R2 or R4 because they both have reachability to that address. Now what we could do is let's go ahead and mess with this topology just a little bit. Let's create a brand new loopback on R3, and we'll go ahead and give it an IP address of 9.9.9.9 with a 32-bit mask. Now if we don't add this to OSPF, it won't be part of the IGP, and R2 won't know how to reach that address, nor will R4. And just to verify that it's not being advertised in OSPF, I'm going to do a quick show IP OSPF interface brief just to make sure that loopback 9 and its directly connected network are not part of OSPF. So great, we've confirmed that loopback 9 isn't part of OSPF, so there's no interface statement for OSPF, there's no network statement in OSPF including that range. So to finish off our mean little trick, what if we set the MPLS LDP router ID to loopback 9, an unreachable address, which we can do right now. So we'll just hop out of interface configuration mode, and in global config, we'll say MPLS LDP router ID, loopback 9, and the keyword force. And that is going to blow away our two neighborships. Now, they're not coming back either, because in the hello messages that we're sending out, we're indicating that the transport address is 9.9.9.9, and R2 and R4 have no clue on how to reach that address, and as a result, they won't be able to form a neighborship with R3. So right now in R3, if we said, hey, please show me the details for LDP discovery, it would show us its router ID. It would also show us what the transport address is being advertised on its interfaces. So in the output, it's showing us, here's our router ID. Here's the hellos and the transport address that we're advertising. And check this out. We are also hearing the hellos from good old 2222 and 4444. However, we're not going to be able to establish a session with them because they cannot reach our transport address. So the hellos are destined to 224.0.0.2, the L router's multicast address. So I bet you if we did this, if we did that command a few times, oh, that's perfect example. See, at the moment, it sees 2, but it doesn't see 4 down here. It just depends on when we issue the command, because those hellos are going to be sent out periodically. And there's a moderately short timeout where they'll drop off. So they'll pop in, simply indicating that we see their hello messages, and then after that short period of time, we'll drop them off. And then once another hello message comes in, we'll see them again. So that's a fun game that we could play that could go on for quite a while. So hit the up arrow key again. There's both of them. There's one of them. There's the other one. But no matter how often we do that game, there won't be any LDP neighborships because they can't reach us. So now that we don't have a functioning MPLS path all the way from R1 to R5, check this out. If we go back to R1 and we do that same trace route again, look at this. Here we have R1 imposing label 221. So he imposes the label here, 221. When R2 gets it, it's forwarding it as a naked IP. It's just doing basic IPv4 routing. So if we looked at R2 and we said, hey, please show us the MPLS forwarding table, what it would show is it would show a local label of 221 with an outgoing label of none, meaning not labeled, because it doesn't have an LSP going this direction. So let's actually do that. Let's go over to R2 just for a moment. And we have some neighbor notifications there, which we expected. And if we do a show MPLS forwarding table for 5.5.5.5, and let's also do a show IPsef for 5.5.5.5, that'll give us a good picture of what's happening. So here's label 221, which R1 imposed as it sent that packet over to R2. And the instructions that R2 is going to follow based on MPLS forwarding is saying that the outgoing interface is not going to have any label. Now this no label is slightly different than POP, because if R3 was directly connected to 5555 as an example and had advertised via LDP that the implicit null was associated with that network, this would show POP, meaning I'm going to pop off the label. But because we don't have any LDP session between R2 and R3, from an MPLS forwarding perspective, it's the end of the road. And by doing the show IPsef for 5555, it says, okay, the next stop is 10.23.0.3, which is R3's interface right there. And you'll notice it doesn't have a label. If this was part of an MPLS path, Ceph would show us the label that would be imposed on that packet, all ready to go in the event we needed to forward on that path. But without that label and without the LSP being built, it's just regular IPv4 routing. So the whole problem is being caused by this guy right here, R3. And what we could do to fix that is, if we wanted to leave 9.9.9.9 as the router ID for R3, and we didn't want to distribute that or advertise it inside of our IGP, what we could do is we could go to interface gig 2/0 and say, I want the transport address for this interface to be the IP address on this interface. And we could go to gig 3.0 and we could tell MPLS, hey, I want the transport address for any sessions with neighbors off of this interface. I want to use the IP address of the interface and not my router ID. And to do that, we'll simply go into each interface configuration mode and tell it exactly that. So we'll make our road trip into interface gig 2/0. We'll say MPLS LDP discovery transport-address space interface. Now, the keyword interface refers to the interface I'm currently in. So the interface command in gig 2/0 says use that IP address for hellos on that interface. For gig 3/0, the interface keyword means use the IP address that's currently on gig 3/0. So you'll notice we have a neighbor up, that's 1. We're looking for 2, and there's the second one. Now both of our neighbors are up. And if we were going to put a capture right here between R2 and R3, it would look something like this. I'm going to go ahead and stop the live capture. We have what we need. I'm also going to stop the capture inside of GNS3. And what I'd like to look at is a hello source from 10.23.0.3. And packet number 4 would be a good example of that. So this is an LDP hello message, which is sourced from the gig 2/0 interface. So the layer 3 header is going to have that IP address no matter what, because that's who's sourcing the hello. But it's the payload inside of that with the transport address that I want to look at with you right now. So I'm going to double click to open up a separate window just for that one packet. And as we open up the LDP payload information in the hello message, so here's our router ID. And if we scroll down under the IPv4 transport address, and open that up, there's our transport address that's now being advertised. Now, because R2 can reach that IP address of 10.2303, it has no problem in building the LDP session. Now, the reality is, as far as building a session, what would actually happen is because R3 has the highest router ID, it's still 9.9.9.9, router 3 would initiate both of those LDP sessions. It would establish a connection to 646 on R2. It would establish a session to TCP port 646 on R4, because R3's LDP router ID is higher now than either R2 or R4. The highest router ID is the initiator of the session for LDP. So here's what I'd like to do. Let's go ahead and verify that R3 really is initiating both sessions, both to R2 and R4. To do that, we're going to do a wire capture, a packet capture on this link and on this link. We'll do that side by side. So let's go ahead and disable MPLS on R3 to begin with a no MPLS IP. So we'll destroy any type of neighborships that we have. We'll start up our captures. So the capture here on the left is the link between R2 and R3, and this capture over here is the link between R3 and R4. All right, so what we're going to do is we're going to go ahead and enable MPLS on R3, which should initiate the LDP communications. And it should be R3 who's initiating those sessions to R2 and R4. So let me go ahead and stop my captures. I'm also going to stop those captures inside GNS3 because I want them to not run forever there as well. And let's take a look. So let's open up the capture between R2 and R3 first. So here's the initialization message, and sure enough, it was initiated by R3 going to R2. So that happened as we expected. I get that out of the way. And on the other side of the fence, between R3 and R4, if we scroll up a little bit, here's the initialization message, and sure enough, it was initiated by 103403, R3, going over to R4. And I'll save both of those Wireshark captures and put them as part of the Nugget Lab files for this course, for the video. Your action item, my friend, is to practice what you have seen. Now, we're still using the same topology that we built in the video called Implementing MPLS. And also, any changes I made in this video, for example, we played with the transit address, we played with the router ID. I am not going to save any of those changes and carry them forward. Those are just for demonstration. And I would encourage you not to save any of those changes that you're testing and playing with either. And that we have a nice solid infrastructure to continue building on as we continue through these videos together. The other thing I'd love for you to do is take a moment and take a look at the very beginning of the video at the opt-out questions, just to make sure that you are now comfortable with those topics and the answers to those questions. I have had a great time, and I'm so glad you joined me for this video. Hey, I hope this has been informative for you, and I'd like to thank you for viewing.